Hi, in the previous video, we actually reviewed our knowledge about differentials. Now, let's apply what we learned into the problem of calculating point elasticity. But before we move there, let's start by reviewing what is this point elasticity. And let me go back first into things you've learned already in your introduction to microeconomics class. So, epsilon d or epsilon qp, this is how we're going to denote demand elasticity or price elasticity of demand, is defined as percentage change in quantity divided by percentage change in price. Okay, so what is this expression telling us? So what we are doing over here is that we are dividing percentage change in quantity by percentage change in price, which means that the number we are going to get is no longer going to be in percentages, right? Those percentages cancel each other out. So we will have some ratio of these percentage changes. So generally, if this is, for example, equal to 2, this tells us that if price changes by 1%, quantity changes by 2%. If this ratio is equal to 0.7, it means that if price increases by 1%, quantity increases by 0.7%. Of course, this result don't make sense in context of elasticity of demand, because the higher the price, the lower the quantity. However, this is straight interpretation of it, but we will go back to this subject. Okay, but look, this means that we can write those expressions a little bit different, because this is percentage change in Q is given by change in Q divided by some initial level of Q, and this whole thing divided by change in P over initial level of P. So initial level of price. So here we have formulas for percentage changes. But look, as we already said, when we use deltas, we talk about bigger changes. And usually when we talk about some linear functions, it doesn't matter, but once the function gets more complicated, deltas do not work properly. So what could we do in a situation like this? Well, probably we can switch to differentials. And look, this actually opens a lot for us. What do I mean by that? Look, if we're gonna be moving not by some amount, by some very, very small amount, we need to change delta Q to dQ, delta P, and delta P to dP. So now look, you can imagine that we are analyzing the entire demand function point by point, because this is what we do. And look, those two expressions, having those expressions, we can work with them a little bit and get something more understandable. Because look, this is the same as dq over q multiplied by p over dp. However, we can multiply in any order, so this is equal to dq over dp multiplied by p over q. But this is still not what we want, because what we want is the formula that does one more thing. What I'm going to do here is I'm going to reverse the order of this variable. So denominator is going to go into numerator and vice versa. And I'm going to have then division instead of multiplication, right? So this is equal to dq dp divided by Q over P. And look, this is the formula for point elasticity. So this formula gives us elasticity of the function at any given point, and in our case of elasticity of demand, of course, at any point on demand function. However, let's look at the components of this expression. First, what do we see over here? This is the derivative of quantity with respect to price. So this is nothing more than a marginal function. On the other hand, this expression over here gives us the quantity per unit of a price, which means that this is an average function. Okay, so look, knowing this expression, we will be actually able to calculate elasticity of demand at any point of the demand function. However, I hope you remember from introduction to microeconomics that demand is elastic, unit elastic, inelastic, if price elasticity of demand is above 1, is equal to 1, or, oh, I'm sorry. Okay, let's say it's smaller than -1, is equal to -1, and is between -1 and 0. Okay, we're going to put it in this way. Because of course demand elasticity needs to be negative. Sometimes in microeconomics class you probably use absolute values, but we will need this sign. Why, you'll see in a second. However, what is important to notice is that if we want to, law of demand says that the lower the price, the higher the quantity. Then of course the higher is going to be the price of a good, the lower must be quantity demanded, right? So we've got this negative relationship between price and quantity. And this results in the negative values of elasticity. And of course, we will call demand elastic if price elasticity of demand is going to be below -1. We're going to call it unit elastic if price elasticity of demand is exactly equal to -1, and we're going to call it inelastic if price elasticity of demand is between 1 and 0. And look, before we move on to the to why are those relationships so important, and why knowing which part of the demand function, demand curve, is actually characterized by what type of elasticity, let's just review everything using a very simple example. Okay, so look, let's just say the demand function is given by Q equals to 100 minus 2P. First question is, can this actually be a demand function? Well, it clearly can, because we see negative relationship between price And quantity, the higher the price, the lower the quantity. Look, we see that if I differentiate quantity with respect to price, I'm getting negative outcome. Okay, so first thing I'm going to do is to find a function that will tell me what is the exact value of the elasticity of this function at any point of this demand curve. So now we use the formula that we know. This is dq dp divided by q over p. So marginal function divided by average function. Okay, we already calculated derivative. This is negative 2. Now we need to divide it by quantity, which is given by 100 minus 2p divided by p. And look, there is not much we can do with this expression. Okay, we will get, if we divide both, so we got negative 2 multiplied by p over 100 minus 2p, right? But I can move this negative 2 over here, and those two will cancel each other out. So we're going to get that this is p over p minus 50. Okay, and look, this result that you see over here is going to be the key. Why? Because this expression that we've got now, so this is p over p minus 50, or negative p over 50 minus p, is definitely showing us what is the elasticity of this demand curve at any point. Okay, so let's just draw this function. Okay, drawing this function is not very problematic. This is a simple linear function. However, you might see some results today that you would not expect. Okay, so we've got Q is equal, if price is 0, Q is equal to 100. And if price is 0, Q is equal to 50. Right? Q is 0. I'm sorry, if Q is 0, price is equal to 50. 0, you move it to the other side. And this is our demand function, right? Now, let's consider 3 different cases of prices, and let's see what's going to be the elasticity. Look, first, let's consider what if price of this good is 25. Look, if price is 25, then price elasticity of demand, which is equal to negative 25 over 50 minus 25, negative 25 divided by 25 is equal to negative 1. So if price is equal to exactly 25, we say that demand is unit elastic. Okay, so what interpretation can we put to this negative 1? If price increases by 1%, quantity demanded decreases by 1%. Okay, look. First, we see that this result makes sense because it's negative. And now, we know that if price is equal to exactly 25, then price elasticity of demand is equal to -1. This means that if price increases by 1%, quantity demanded decreases by exactly 1%. Okay, so let's consider a different price level. Let's just say that now price is 30. Okay, so look, again we can use the same formula that we've already calculated for this particular case. So we've got that this is -30 over 50 minus 30, right? We still use the same expression. So this is -30 over 20 or -1.5. So in this case, we say that demand is elastic. Okay, so what would be the interpretation of this result? If price increases by 1%, quantity decreases, quantity demanded decreases by 1.5%. Okay, so what is the main difference between these two results? Well, look, we call this elastic. This case elastic because if price increases by 1%, quantity demanded actually decreases by more than 1%. Decreases by 1.5%. Okay, so where can we find this case over here? Well, this is the case where price is above this level, and actually in those circumstances, we can say that this part of the linear demand curve, please notice it, this is a linear demand curve, is actually elastic. This is elastic part. Here, EQP is lower than -1. Okay, so you probably know where I'm going with this in terms of the third case. So let's see what now happens if price happens to be 20. If price happens to be 20, then we use our formulation, we get that this is 20, -20 over 50 minus 20. This is -20 over 30, or this is equal to -2.3. So look, now we've got the last possible case. Now, demand is inelastic. Why is it inelastic? Because if price increases by 1%, quantity demanded decreases by 2 over 3 of Okay, so look, we see that in this case, if price increases by 1%, quantity demanded decreases by less than 1%. Okay. So, we would find this point, of course, somewhere over here, and we can say that generally this part of the demand curve is inelastic. So here, price elasticity of demand is somewhere between -1 and 0. Of course, the case in the middle is the case of unit elasticity. Okay, now let's think about it for a while. Why is this important? Okay, because look, if demand you are facing is inelastic, which means that if price increases by 1%, quantity demanded decreases by, for example, 2–3%, so less than 1%. This means that if you increase the price of your product, you will make more money. Why? Because if the price you're charging is going to go up by 1%, actually quantity that you are selling will drop by less than 1%. So look, what does it mean is that if we are on inelastic part of demand curve, we should be increasing the price. Okay, but what if we are in a case of elastic demand? If price increases by 1%, quantity demanded decreases by 1.5%. So look, it means that if you increase the price, in this case, you will lose a lot of customers. So in this case, the rational thing to do is simply to decline the price. And look, this actually points us to unit elasticity as being the best price that we can charge. And actually, there is this very, very strong argument why this is the case. But before we actually go to this case, let me just write you down an explanation of price elasticity of demand in terms of interpretation. Look, if price elasticity of demand is equal to some x, so negative x, right? Okay, let me just make it clear that this is negative x. How do we interpret this? We interpret this always in the same way, that if price increases by 1%, and look, this 1% is always here. Always, if price increases by 1%, then the quantity demanded decreases by X %. And this is the proper interpretation. Okay, knowing this, we can actually start figuring out what is the connection between price elasticity and revenues of the company. And when we want to elaborate on such phenomenon, I think the best starting point is the model of pure sale. Okay, so what is this pure sale model? Imagine a situation like that. You own a parking lot. Okay, so let's just say that this is your parking lot. You need to pay for this parking lot a rent, let's just say $2,000 a month. And also, in the corner of the parking lot, there's a small building for the security and a person who actually takes the money from everyone who is using the parking. Let's just say that you need to pay them $3,000. Okay, and look, this is your business that you've got over here. You want you want to charge people for parking their cars on your parking lot, right? The cost of your business on a monthly basis is always the same. It's exactly $5,000, right? There's no point, regardless of how many cars there's going to be there over a month, you will still pay the rent of $2,000 and you will have to pay the salary of $3,000. So look, if you want to look at it from purely microeconomic perspective, all the costs that you've got are fixed costs. What does it mean is that if more cars parks on your parking lot, you will make exactly the same amount of money as if there were no cars parked. You will pay the same amount of money to the, of course, to the guard and to the person that rented you the parking lot. So in your business, those costs are fixed, right? So the only question is, what is the price you should charge the people who want to park their cars? Well, and actually this is where the elasticity becomes a key concept. Okay, let's look at the profit of your function of your company. Look, you will get total revenue that is given by P, which is price of, let's just say, 1 day spent on a parking lot, times quantity, which is how many cars is currently parking at your parking lot. Then you need to subtract from it total cost. However, in this particular case, your total cost is only a fixed cost, right? So this is a number. This is a number that is not changing regardless of how many cars do you wanna. How many cars do you wanna? Doesn't matter how many cars you actually have on your parking lot. Okay, so now, look, very often we think like we should use all the spaces in the parking lot. However, this is not what a rational person would do. And let me explain to you why. Okay, look, if your profit is given by total revenue minus fixed cost, it means that you pay the same amount to your factors of production every every month. So the only thing that you can actually decide about is total revenue. And you want to find maximum of this total revenue. Okay, so let's do it. Look, if we have let's just say that we have some demand function d of p. So it doesn't matter what is the form of this function. It needs to just have the property of being a demand function. What does it mean? It means that the derivative dq dp is lower than 0. So the higher the price, the lower the demand, right? Makes perfect sense. Okay. Now, your profit of your company is given by total revenue minus fixed cost, right? But your total revenue is nothing more than price times quantity minus fixed cost, right? However, we know that quantity is also a function of a price, right? So we get that this is P times D of P minus fixed cost. Okay, now what I'm going to do is that I want to maximize this profit, right? So what should I do? I should differentiate profit with respect to price, and I should see what is the price for which the profit here is the highest, right? Okay, and look, so I'm differentiating. Look, here I have two expressions. One is price, and the second is demand as a function of price. So in order to differentiate it, I need to use the product rule. So I get that this is d p plus p times derivative of this, which is dq dp. Also, we can easily notice that dp is equal to q, right? Okay, now I'm differentiating further. Fixed cost is fixed. It's a number, right? It is a number. So it is gone in differentiation. So all we need to do now is to compare this with 0. And let's see what we got. We've got that q plus p times dq dp must be equal to 0. If I'm going to move this q to the other hand side of the equation, I'm going to get that p times dq dp equals to negative q. And now look, if I'm going to divide both sides by q, I'm going to get dq dp times p divided by q equals to negative 1, right? And if I'm going to change this, which gets us to our final result, that this company is going to maximize the profit at a point where price elasticity of demand is equal to exactly -1. Okay, look, this is actually a very profound result, because it tells us that when we can't ignore the costs, because costs are fixed, we should charge such a price for which price elasticity of demand is equal to 0. -1. So we've got a unit elastic. Now, so I'm going to explain this using a very simple example. Okay, look. Imagine a situation like this, that demand function is given by A minus B times B. That should look familiar from what we did with the market model. So this is a typical demand function. Okay, now let's calculate total revenue. Total revenue is price times quantity, right? So this is, in other words, price times A minus B times B, which is equal to A times B minus B squared. What is this? This looks like a parabola, right? Okay, so look, if I would like to graph total revenue over here and price over here, what would I get? Well, I would get, what we definitely know is that, look, if price is 0, total revenue will definitely be equal to 0. However, there is something also known as prohibitive price. Prohibitive price, look, if I'm gonna plot this on the graph, Q over here, how does it look? A, it goes down, it goes down, it goes down, until the point where we are A over B, right? As we always had in our cases. So what is this prohibitive price? Well, this is our A over B, right? Look, with this price, quantity equals to 0. So the second thing I can put over here on this graph, except for price 0, is price A over B, for which the value of total revenue is also 0. Okay, so, but now, let's look for the maximum, right? All we need to do is to find first derivative of marginal revenue, this time with respect to price. Okay, so we get that this is A minus 2B minus 2B, B, right? Then we need to equalize this with 0. And look, out of this we get the price for which there is an equilibrium is equal to, for which there is a maximum, is is OA over 2B. Okay, so what do we know now? We know that somewhere in between those two, between 0 and A over B, there is a price. A over 2B, for which total revenue takes maximum. So, what could we see over here? Look, as price increases, at the beginning, total revenue increases until it reaches this maximum value over here, and then it starts to decline. And here, we've got maximum. And look, for our purpose, for our model, this maximum of revenue is maximum of profit. Why? Because we have only fixed cost. So the point where the revenue is highest is also giving us our maximum profit. So here, what you see is profit maximized. So this is the highest profit this company can expect. Okay, but what is the relationship between this and price elasticity of demand. Maybe we should calculate price elasticity of demand of this particular function. Let's do so. So we've got that AQE, epsilon QP is price elasticity of demand is dQ dP times divided by Q over P, right? So in this case, dQ dP is simply negative P, right? Q, okay, so let's put P over here already, and Q is A minus B P. Okay, so this is the formula that gives us elasticity of this function at any given point. Now, what will happen if the price I'm going to choose is going to be A over 2B? Well, let's see. So, we've got that this is equal to negative B over A over 2B times A minus B times A over 2B. Okay, I think we're getting somewhere with this. We clearly we see that those two cancel each other out. So, so we've got A over 2B's, and also A's over here and over here are canceling each other out. So what do we get? We get that this is negative B times 1 over 2B times times 1 minus 1 over 2. Okay, so we get that this is negative B 1 times 1 over 2B times 2, which gives us B 1 over which gives us 1 over B times minus B. This is negative 1. Again, I hope you can see that the point at which we are receiving maximum of the revenue is the same point when price elasticity of demand is equal to negative 1. Okay, now maybe some intuition behind it. Okay, I hope you can see it quite easily even from this graph. Look, if, let's just say that price at the beginning is very low, right? Price is P0. At price P0, we can sell a lot of units, right? Q0 units. What is the total revenue? Total revenue is price times quantity. So look, total revenue is this entire rectangle. Now, let's see what happens if I'm going to increase the price to some P1. Well, we will be able to sell less units, some Q1, but at a higher price. So look, actually our new total revenue is way, way bigger. Because look, when price is very low, increasing the price is a good idea because percentage increase in quantity is bigger than the percentage increase in price. This is what we get, of course, when demand over here is inelastic, right? Because I increase price by something, but the quantity increases by less in percentage terms. So when demand is inelastic. Now let's consider a different possibility. Look, if now price is, let's just say, at some P2, then our total revenue is this big rectangle. Now look, what will happen if I'm going to increase the price to some P3? Well, the total revenue is going to be this smaller rectangular, because look, now when price is when demand schedule is elastic, this simply means that when the price is increased by 1%, quantity declines by more than 1%. And as a result, the total revenue we are getting is simply smaller. Okay, and look, now, knowing this, we can combine those two graphs actually into just one graph that summarizes all this information. Okay, I'm going to make it a little bit smaller, but I hope you will be able to see everything. Okay, so look, imagine putting together everything that we said today. So here is price, here is total revenue, here is quantity demanded. Okay, so we got this. It starts at A, ends up at A over B, right? We discussed that with this demand function, our total revenue will look like this. Where the maximum is given at A over 2B. Now, what do we know about this maximum? We know that this maximum happens to take place where price elasticity of demand is equal to -1. And look, what do we learn from this? Look, oh, of course, and here we have fixed cost only. So with fixed cost only, of course, our maximum total revenue is also maximum profit. Now, look, what do we have over here? This part, blue and okay, green. This part of the demand curve is called inelastic. So, what is the rational thing to do when we are here? Well, we see that price is very low and quantity is very high. So, rational thing to do is to increase price. And look, as we increase price, we have this effect to the beginning that price elasticity of demand is between -1 and 0. So, we have inelastic demand. Increases in prices are associated with lower percentages. Percentage increase in prices are associated with lower than 1% increases in demand. So here we should be increasing the price, and as a result, increasing total revenue. Over here, however, we've got the opposite situation. Here demand is elastic. What does it mean? The higher the price, the lower here, decreasing the price will cause, by 1%, will cause the quantity, increasing the price by 1% will decrease the quantity by more than 1%. What is the rational thing to do? Here, we should be declining the price, and eventually this will also lead us to maximum total revenue. Okay, so now we have formally seen how to calculate price elasticity of demand, and why is it so important to know price elasticity of demand. What I want you to remember from this is also how to put interpretation on price of elasticity of demand, and what is the relationship between elasticity of demand, even for a very simple linear function as we devised here, and total revenue function, especially in the context of pure sale problem. Okay, so this is it about this topic. In the next video, we are going to discuss total differentials. Take care.